So we're going to just be looking at a graph and analyzing them, just like some basic information to see how to give a story to a graph. So we're going to start with this first one that says Ms. Romero wants to record the exercise over 10 days. She wants to record the number of miles she runs every day. So looking at the first one, we're going to write a general continuous graph, meaning no disconnect, not discrete. She's going to increase her number of miles each day, and the maximum will be reached at day 6, and it's going to decrease afterwards. So let's go ahead and label our x-axis. This is going to be the day, and this is going to be the number of miles. So we're going to start with day 6, just because that should be the maximum. Let's say she does a maximum of 9 miles on day 6. And then after that, so let's say 9. After that, we're going to go to the left, and it should decrease before that, and it should increase after that. So let's say on the previous days, it just goes down something like this. After that, it decreases. So again, let's say her graph increases for 6 days, and then it decreases afterwards. It's continuous because we were told it's continuous. And this is just an example of that taking place. Let's go ahead and look at the graph to the right. We're also going to label it the same. So let's go ahead and do that. All right, so we have our graph labeled now. Go ahead and do so if you haven't done it. Positive needed. So we're going to go ahead and look at the graph. So we see it's starting off by decreasing first, then it stays constant, and then the number of miles drops again. So we're going to write out a story given all this information. So let's go ahead and start writing that out. So first piece is going to be from days 0 to 5, the number of miles decrease. So we get on the first 5 days, Ms. Romero decreases the number of miles from 20 to 15 miles. Now we're going to do the next part from days 5 to 10. She runs the same amount of miles, which is 15 every day. And now we have on days 5 to 10, which is these right here, she runs 15 miles daily. Now let's go into that last piece. And we have from days 10 through 20, she decreases her number of miles from 15 to, let's say this little guy right here, that's going to be 7. All right, so here's the last piece. From days 10 through 20, she decreases her miles from 15 to 7. Go ahead and write this out, and let's move on to the next problem afterwards. All right, this last problem, we have a quadratic. So the word problem is a rocket is fired from a height of 1.3 meters with an initial velocity of 45 meters. They give us the formula. H is the height, T is the time in seconds. So we're going to be looking at this problem where it says Johnny was given this problem and was asked to graph the function and explain the path of the rocket. His graph is shown on the right, this one right here. Ms. Velasquez told him his summary, which is right here, was perfect, but that there is a minor error in his graph. What is Johnny's error? So let's just take a quick look at his summary. The rocket begins at a height of 1.3 meters, which is right here somewhere. It goes up to a maximum height of 105, which is right there. And the y value and the time is 5 seconds. So that's approximately the middle right there at 5 seconds. Then the rocket descends and hits the ground after 9.5 seconds. So his summary is good. So we have to now decide what is wrong with the graph, because those parts of the graph that I highlighted seem to be fine. But what is it that's not right with the rocket? So try to see if you can figure it out. Pause the video for a minute or so, and then come back and see what's wrong with the rocket's graph. If not, just write it out. Okay, so what's wrong with this picture? So far, most of it seems to be fine. The thing is, once the rocket hits the ground, the problem ends. In this case, this parabola keeps on going right here, which means that the rocket is negative 10 feet and negative 20 feet below the ground. But the problem says that the rocket goes down and it hits the ground. That's when it stops. So we cannot have that happening. When it comes to real world problems, they have to have constrictions. In this case, the quadrant one is our constriction. We cannot have stuff here or there, because before the rocket is launched on the left, it's not 10 and 20 feet underground. When the rocket lands on the ground, it's not going to keep on going, so it stops. So here we have to make sure we take care of those things and not include them in our graph. Although this graph is done perfectly for a generic XY plane, for a graph, it doesn't make sense in this scenario. So let's go ahead and write that out. So here's one way to summarize. The graph should only appear in quadrant 1 since the problem does not include negative height. So one thing you can do is just kind of cross this piece out. That will make it a perfect graph for this word problem. All right, go ahead and start your practice.